Good morning, student. In the previous lecture, we saw the timer programming in 8051. So now in this lecture, we will see the basic register that we use in timer programming. So what are the basic registers? So the two timer register, timer 0 and timer 1 are 16-bit wide. Since 8051 has 8-bit architecture and 16-bit timer is accessed as a two separate register of lower byte and higher byte. The 8051 microcontroller is a 8-bit register, but it has a two timer register, timer 0 and timer 1. Each register is a 16-bit wide, but 8051 is a 8-bit, so therefore these two 16-bit register is divided into two separate registers, lower byte and higher byte. So for timer 0, for timer 0, TL0 is the lower byte of timer 0 and TH0 is the higher byte of timer 0. Here the timer 0 register. The lower byte register of timer 0 is called as the TL0. That means timer 0 lower byte, and higher, that means upper byte of register, is referred to as the TH0. That means timer 0 higher byte. Okay. Here the timer 0 register. This is the timer 0 register. This is the lower byte of timer 0. D0, D1, D2, D3, D4, D5, D6, D7 are the lower byte of timer 0 register. And D8, D9, D10, D11, D12, D13, D14 and D15 are the higher byte of timer 0 register. So this register can be accessed like any other register, such as A register, B register, R0, R1, R2, etc. The instructions move TL0, hash 0FH, move the value 4FH into a TL0. So this register TL0 and TH0 register can be accessed as other register when accumulator register, B register and RN register, which is from R0 to R7. In the same way, we can access the TL0 and TH register. Then there is the instructions move TL0, hash 4FH. That means this 4FH value is loaded in a TL0 register. So this 4F value is loaded in this TL0 register. So the lower byte of timer 0. So this register can be also be like other register. For example, move rs move r5 th0, save th0 higher byte of timer 0 in r5. So similarly, the data stored in this higher byte, that means this higher register, the data stored in this higher register can be loaded into or move into the r5 registers. So these two registers we use similarly in the manner like accumulator register. Okay, now the next register is the timer register. The timer 1 register is also split into two bytes, TL1. TL means timer 1 lower byte, and th1 means timer 1 upper byte. So these registers are accessible in the same way as a register of timer 0. So, timer 1 register is accessed same way as the timer 0. Why timer 0 and timer 1 is split into two separate registers? Because the timer 0 and timer 1 is our 16 byte register, but our microcontroller is a 8-bit microcontroller. So that's why timer 0 and timer 1 are split into two separate registers, th0 and th1. th0 means higher byte of timer 0 and TL0 means lower byte of timer 0, and THL means lower byte of timer 1 and TH1 means higher byte of timer 1. Okay. Now beside these two register, timer 0 and timer 1, there are one more register which is called as timer mode register. This register, T mode register, controls the operation of timers. The Intel has four operating modes. The timer has four operating modes. Both the timers use the register called as a tmod register. So this tmod register is a special function register. It is the SFR. So its function is to control the operation of timer registers. This timer register, timer 0 and timer 1, is used as a delay generation or as a event counter. So the operation of that register is controlled by a tmod register. Okay. So this timer, the timer 0 and timer 1, both timer have four operating mode: mode 0, mode 1, mode 2, and mode 3. So these two registers are programmed in different modes. So the timer has a four operating mode. Both the timer use register called as a T-mode register, and T-mode means timer mode control register. Timer mode control register, and this is the special function register. Its function is to control the operation of timer 0 and timer 1 register. To set the various timer operating mode, the T-mode is an 8-bit register in which lower 4 bit are set aside for timer 0 and upper 4 bit is set aside for timer 1. So T-mode register is a 8-bit register. So its lower 4 bit is used for timer 0 register, and its upper 4 bit is used for a timer 1 register. So in each case, the lower 2 bits are used to set the timer mode, and the upper 2 bits are specify the operations. So according to this data frame of T-mode register, the T-mode is a 8-bit register starting from here D0, starting from LSB, D0, D1, D2, D3, D4, D5, D6, and D7. So lower 4 bit, that means D0, D0, D1, D2, and D3. This lower 4 bit is used for a timer 0, and upper 4 bit is used for a timer 1. Okay. Now the gate. The suppose of this bit is start and stop the timer. It can be done either by software or by hardware control. The hardware way to starting and stopping the timer is external source is achieved by making gate is equals to 1 in Tmod register. So whenever we need to start the timer is start or stop by two ways, either hardware or software. When we use hardware way to starting and stopping the timer, then this gate bit is make a 1. It is gate bit make to at logic high. So the purpose of this bit is to start and stop timer. So the purpose of this gate bit, both the time in timer 1 and in timer 0, both the gate bits are used for starting and stopping the timer. So there are two methods for starting and stopping the timer. First is hardware method and second is software method. So by hardware method, for so far by by using hardware method, we can start and stop the timer. So but for this purpose, the gate terminal, so gate bit is made to 1, that means it is logic high. So the hardware way of starting and stopping the timer by external source is achieved by making gate is equals to 1. That means when we make this bit to 1, then timer and then the timer are start and stop by a external source. The start and stop of this timer are controlled by a software by timer start bit TR0 and TR1. This is achieved by the instruction set bit TR1 and clear bit TR1 for timer 1, and set bit TR0 and clear 0 for timer 0. The set and for by using software method, we can start and stop the timer by using this simple TR timer start bit. TR means timer start bit. So by using this bit, we can start and stop the timer by software method. So by software method, we can start the timer by using instruction set bit TR1. Set bit TR1 means start timer 1, and clear TR1. Clear TR1 means stop timer 1. TR is a timer and one number is indicator which timer we have to use, either timer 0 or timer 1. And set bit TR0, that means start timer 0, and clear TR0 means stop timer 0. So set bit TR0 and clear TR0 for timer 0. So when we want to start and stop the timer by software way, we can use this instruction set bit and clear. So So set bit instruction start the timer and it is stopped by clear instructions. So these instructions start and stop the timer as long as gate is equals to 0 in T-mod registers. So when we make the gate bit to 0, then timer is start and stop by software method, and when this gate bit is 1, then timer start and stop by a hardware method. So by starting and stopping the timer, we use this bit, and this method, so there are two methods, starting and stopping the timer, hardware method and software method. When we make this get bit is equal to 1, then timer is start and stop by the hardware method, and when we make this bit, that means get bit to 0, then timer is start and stop by a software method. Okay, so in T-mod register, the lower 4 bit is used for timer 0 and higher 4 bit is for timer 1, but the data frame is same for all the timers, timer 0 and timer 1. Here the last bit is get, then counter timer M1 M0. Here the for timer 1 the data frame is get, timer counter M1 and M0. Both the timer use same data bit, same data frame. Okay, now the next terminal is counter or timer. So the timer 0 and timer 1 in the 8051 can be used as a dual operations. So timer is used for a time delay generation, and it also used for a event counter, it also used for event counter, so it perform dual function. So timers in 8051 microcontroller perform dual functions. It is used for either time delay generation or by event counter, or to count the event. So this bit in the T-mod register is used to decide whether the timer is used as a timer or as event counter. So when the both timer 0 and timer can be used as a timer for delay generation and can be used as a event counter. So when we use timer as a delay generation and when we use timer for a event counter, so this is decided by the this bit, this is decided by the timer counter bit of T-mod register. Okay, so this bit in the T-mod register is used to decide whether timer is used as a timer for time delay generation or event counter for counting the event. With this bit is equal to 0, then timer operation is activated. Then when this bit is equal to 0, then timer used as a timer for time delay generation. And if this bit is used as a 1, is made to 1, then this timer is used as a event counter. If counter timer is equal to 1 and event counter operation is unable. Here for get terminal, for get bit, we use in 8051 microcontroller, we use software method to start and stop the timer. This get bit, the function of this get bit is to start and stop the timer, and it is done by either hardware or software. So in 8051 microcontroller we use software method to start and stop the timer. So by using software method, so for by using software method, so this get terminal is equal to 0, this get terminal is, so this get bit is equal to 0, because when this bit is equal, when this get bit is 1, then timer is start and stop by a hardware method, but we want to start and stop the timer by software method, so therefore we make this bit to 0. Okay, now the counter timer. So when the this bit is equal to 1 0, when counter timer bit, this bit is equal to 0, then timer is used as a timer for time delay generation, and when this bit is equal to 1, then timer is used as a event counter. Here this bit in the T-mod register is used to decide whether the timer is used as a timer or as a event counter. If if a counter and timer is equals to 0, then timer operation is activated, and when this bit is equal to 1, then event counter operation is unable. So it is depend on programmer which operation it has to be used, either time delay generation or event counter. Okay, now the next bit of T-mod register is M1 and M0 for timer 1 and timer 0. So M1 and M0, the timer operate in 4 different modes. The mode selection is done by M1 and M0 as given in following table. We M1 and M0 is equals to 0, then mode 0 is selected. When 0 1, then mode 1 is selected. When 1 0, then mode 2 is selected. 1 1, then mode 3 is selected. So mode 0 So for mode 0 is a 13-bit timer mode. So 8-bit timer. th means the timer. Thx means either timer 0 or timer 1 higher bit, or tlx means either timer 0 or timer 1 higher lower bit as a 5-bit prescaler. Then mode 1 is a 16-bit timer. So 16-bit timer counter means thx means higher bit of timer 0 or 0 or timer 1, or tlx means lower bit of timer 0 and 1. So there is no prescaler. So mode 2 is a 8-bit timer, 8-bit auto reload timer counter. So thx means a higher bit of timer 0 or timer 1 hold the value which is to be reloaded into a tlx, that means a lower bit of lower bits each time it overflow. And mode 3 is split timer mode. Now timer 0, timer mode 0 and mode 1. So the timer mode 0 and timer mode 1, the programming between these two modes are similar. The timer counter can be operated in one of the four modes by under the software control. In mode 0, timer counter will behave like 13-bit counter. When counter overflow, TF0 and TF1, TF0 is the timer flag for timer 0 and TF1 means timer flag for timer 1. But bit in TCON timer control. So TF0 and TF1 are the timer flag of TCON register. So TCON is the timer control register which is also a SFR. So this will cause the appropriate timer interrupt. Both timer 0 and timer 1 will operate in the same way for mode 0. So operation of timer in mode 1 is same as it is for mode 0, with the exception that all 16 bits of the timer are used instead of only 13 bit. So in the programming of mode 0 and mode 1 is similar, but the only difference is that the mode 0 is a 13 bit and mode 1 is a 16 bit. Okay, now the timer mode. In a timer mode 2, in timer mode 2, the timer is set up as a 8-bit counter which automatically reload whenever the overflow condition is detected. So timer mode 2 is used for auto reload. So in mode 2, only higher byte is loaded, and lower byte is a copy the data loaded in higher byte. So in mode 2, the timer is set up as a 8-bit counter which is automatically reload whenever overflow condition is detected. So lower byte of timer TL0 and TL1 is used as a counter, and higher byte of timer TH0 and TH1 hold the reloaded value of the counter. Okay, so in mode 2, in mode 2 is a 16-bit register. So out of 16 bit, the upper 8 bit, in upper 8 bit the data is loaded, and lower 8 bit is automatically reload. That means it copy the data stored in a higher bit. Okay, so when the timer counter overflow, the value of THX loaded into TLX. So when the timer is overflow, the value stored in higher byte is loaded in a lower byte. Okay, so and continue counting from reloaded value. So both timer 0 and timer 1 function identically in mode 2. So timer 1 is often used in this mode to generate the baud rate for universal synchronous receiver transmitters. So timer 1 is used in this mode for a serial communication purpose. Okay. Now the timer mode 3. The timer 0 and 1 may be programmed to be in timer 0 and timer 1 are programmed in mode 0, 1 or 2 independently. This is not true for mode 3. So that means timer 0 and timer 1 cannot be programmed in mode 3. So the timer do not operate independently if mode 3 is chosen for timer 0. So in mode 3, timer 0 becomes 2 8-bit counter which is implemented in TH0 and TL0. So the counter implement in TL0 maintain control of all over the 0 flag. So but the counter in TH0 take over the control flag in a TCON taken from timer 1. So this implies that timer 1 can no longer pose interrupt. So it can be used for any purpose which will not require the overflow interrupt, such as the bounded generation for UART. So in a mode 0, the timer 0 and timer 1 cannot be programmed because the timer 0 become two 8-byte counters that implement a TH0 and TL0. So it is not possible in timer in mode 3. So therefore the timer 0 and timer 1 cannot be programmed in mode 3. It will be programmed in only mode 0, mode 1 and mode 2. Here are the some examples. Indicate mode and timer selected for each of the following. So move tmod comma hash 0f, move tmod hash comma move tmod comma hash 01h. That means 01 value is a load in a tmod register. So 01. So 01 means 00000001. So when we load this value in a tmod register, then mode 1 of timer 0 is selected here. This is the tmod register. When we use 0 1 value 0 0 0 0 and 0 0 0 1. Therefore all the bits of timer 1 is 0. Timer 1 is 0. Therefore timer 1 is not selected. Now the in timer 0 0 0 0 1. So get terminal is 0. That means timer is a start and stop by software method. This timer counter bit is 0. Therefore so this bit is 0. That means that the timer 0 is used for the time delay generation, and the m1 and m0 combination is 0 and 1. So for 0 1 mode 0 is selected, so timer timer 0 and mode 1 0 1 0 1 means mode 0 0 1 means mode 1. So mode 1 and timer 0 is selected. When we put 20h value in a tmod register, move tmod comma hash 20h. So when we load this value in a tmod register, then 22 means 0010 So here 20 means 2 0. So 2 are loaded in timer 1 and 0 are loaded in timer 0. So 2. So binary number of 2 is 0 0 1 0. So get terminal is 0. So timer is start and stop by hardware, so software, and this timer counter is also is 0. So timer is used as a time delay, and the combination of m1 m0 is 1 0. 1 0 means mode 2. 10 means mode 2. So timer 1 mode 2 is selected, and here in timer 0 all the bits are 0 0. So timer 0 is not selected. So timer 1 mode 2 is selected. Timer 1 mode 2 is selected. So in similar way, move tmod comma hash 12h. Move tmod comma hash 12h. When we load this 12h value in a tmod register, that means 12 means 1 0 0 1 0 0 1 0. So mode 2 of timer 0 and mode 1 of timer 1 are selected. So we put the 1 2 value 12 value. So 1 is loaded in timer 1 and 2 is loaded in a timer 0. So 1 is loaded in timer 1, and the binary number and the binary code for 1 is 0 0 0 1 0 0 0 1. So that means gate is 0. The timer is start and stop by software. This timer counter is 0. So it is used for time delay. And the 0 1 0 1 means 0 1 means mode 1. So timer 1 mode 1. Timer 1 mode 1 is selected, and here in timer 0 2 number is loaded. So binary code for 2 is 0 0 1 0. So gate is 0. So timer is start and stop by software. This timer counter bit is also a 0. So this timer is used for time delay generation, and the combination of m1 m0 is 1 0. So for 1 0 it is mode 2. So timer 0 mode 2, timer 1 mode 1, and timer 0 mode 2 is selected here. Mode 2 timer 0. and mode 1 for timer 1 are selected. So depending upon which timer and which mode we have to use for programming, so depending upon that we can load the tmod register with a particular value. Okay, so this is all about tmod register. Now the next example is find the timer clock frequency and its period for various 8051 base system with the following crystal frequency. Suppose there are the crystal frequency, that means microcontroller frequency is 12 megahertz. So depending upon this microcontroller frequency, how we calculate the timer frequency? The timer is used for a time delay generation. So for time delay generation, it requires some time delay. So how we calculate the time delay of any timer? So for calculating the time delay, we need a timer frequency. We need a timer frequency, and this timer frequency is calculated by using a microcontroller crystal frequency. Suppose the microcontroller crystal frequency is a 12 megahertz. So how we calculate the timer frequency? So this crystal microcontroller crystal frequency is divided by 12, and then we get the timer frequency here. The crystal oscillator frequency is divided by 12, which is equal to a timer frequency. So here the crystal oscillator frequency is a 12 megahertz. So this 12 megahertz frequency is divided by a 12. Here the 12 megahertz frequency is divided by 12. Then we get the frequency of 1 megahertz. So this 1 megahertz frequency is our timer frequency. So if we get the timer frequency, then we can find the time delay. So how we find the time delay? So time is a reciprocal of frequency. So time delay is equal to 1 upon timer frequency, and timer frequency is 1 megahertz, which is 1 microsecond. Okay, now the crystal oscillator frequency is 16 megahertz. So if the crystal oscillator frequency is 16 megahertz, then this frequency is divided by 12, then we get 1.33 megahertz timer frequency. Once we get the timer frequency, then we calculate the time period. So time period is equal to 1 upon timer frequency. So we get the time delay 0.75 microseconds for crystal frequency 16 megahertz, and for 12 megahertz we get 1 microseconds time delay. So in this way we can calculate the timer frequency and time delay. So the formula for timer frequency is crystal oscillator frequency is divided by 12. So that means timer frequency is 1/12 of the crystal oscillator frequency. Okay, so now we will stop here. In next lecture we will continue with mode 1 programming. Now we will stop here. Thank you so much.